In introduction to probability, first we are going to see what is the probability. Probability is a numerical measure of the likelihood that an event will occur. Okay, for every probability, we must have some event or experiment. Okay, here the value of the probability always lies between 0 to 1. The value of the probability always lies between 0 to 1. Here, what is 0 and what is 1? If the value of the probability nearer to 0, suppose if the value is 0.123 means then it is nearer to 0, then the event is unlikely to occur. Similarly, if the value nearer to 1 means then the event is almost to occur. Suppose if I am having for a particular event, if I am having the value as 0.9 means then it is nearer to 1. So at the maximum the probability will happen. Okay. So the value lies between 0 to 1. This is known as the probability. Okay. Here we are having some basic concepts. Basic concepts means first of all the experiment. For calculating the value of the probability, we are in need of some experiment. If the experiment is undergoing means, then only the outcome will exist. From that outcome only we have to calculate the probability. Okay. For that we are in need of experiment. So what is experiment? Experiment is a process whose result is well defined. The result is well defined. Well defined means it is predefined. Predefined. Here are some example. That is tossing a coin, throwing a glass. Tossing a coin means suppose if I am tossing a single coin means it will comes up head or tail. So already the outcome is well defined. Well defined. Either it may be head or tail. Similarly, if I am throwing a glass means I know that glass will broken. Okay, broken. That is predefined. Predefined. That is all well defined. I know that the glass is broken. These type of activities are known as experiment. Okay. Here, in this experiment, there are two types. The first one is the deterministic experiment, and the second one is the random experiment. What is known as deterministic? Deterministic means we know the value prior in advance. We know the sequence or we know the outcome prior in advance. In such cases, we can prove that it is deterministic. Okay. Here the definition is it is an experiment. Deterministic. It is an experiment whose outcome can be predicted with certainty under initially identical condition. Okay, it is an experiment whose outcome can be predicted. Whose outcome can be predicted with certainty under identical condition. Okay, already it is defined. Here the example is given here. Throwing a glass. Suppose if I am throwing a glass means if a glass is thrown means what will happen? It will broken. I know if a glass is thrown means it will broken. And so here the outcome broken is already determined. So this kind of examples is given for deterministic experiment. Next one is the random experiment. The random experiment, random, what is random? Random means it may occur or it may not occur. Okay, the experiment in which all possible outcomes are known, but it is not possible to predict the exact outcome in advance. So we know the outcome, but we cannot predict the outcome in advance. In advance. Here are some example. First one is the tossing a coin and throwing a die. Suppose if I am tossing a single coin means it may be head, head or tail, but we cannot predict the outcome in advance. Okay. Similarly, for throwing a die. Throwing a die means I will get the value from 1 to 6. 1 to 6 but I cannot predict as the outcome as 1 or 2 or 6 like that. Okay. So this kind of experiment is known as a random experiment. The next one is sample space. We came across this word in many times. Here sample space is nothing but the outcomes. The outcome of the experiment is known as the sample space. Here the definition is the set of all possible outcomes of a random experiment is known as the sample space of the experiment. Okay, the outcome of the experiment is known as the sample space. What are all the possibilities for the experiment? It can be collected in a single set that is known as the sample space. The sample space may be either discrete or continuous. It may be discrete or continuous. Suppose if it has discrete case means, for example, if I'm tossing two coin means what are all the outcomes happen? Either it may be two head or two tail, or the first one is head and second one is tail, or the first one is tail and the second one is head. These are all the maximum possibilities that occurs when I am tossing two coins. Okay. Beyond that, it may be no other chances. Okay. Okay. If I am tossing two coins means these are all the outcomes and these are all the discrete values. So it comes under the discrete case. Next one is the continuous case. Continuous case is nothing but here I am taking an example as lifetime of a transistor. Here the lifetime of the transistor is nothing but it may goes on 1 hour, 2 hour, 3 hour, 10 hours, 50 hours, 100 hours. I don't know what is the lifetime, but it goes on from 0 to infinity. Infinity. So in such cases, it is known as continuous cases. Okay, lifetime of a transistor in hours is given as capital S. S is nothing but the sample space. This sample space is given as set of all x such that 0 less than or equal to x less than infinity. Here the equal to case. What is equal to case? X may be take the value of 0. X equal to 0 means what is the meaning? The transistor will fall down initially. It may not work initially. Okay, this kind of lifetime is known as equal to cases to 0. Next one, the event. Any subset E of the sample space is known as an event. What is event? Suppose if I am taking a subset from the sample space, then it is known as an event. It is also defined as a set consisting of possible outcomes of the experiment. There are many events. Here we are going to discuss two events. The first one is the mutually exclusive event. The second one is the independent events. What is mutually exclusive events? Two events A and B are said to be mutually exclusive. Mutually exclusive if it has no common outcome. If it has no common outcome. That is P of probability of A intersection B equal to MT. Okay. If I am taking the intersection and after that the probability, after that I am taking the probability means that should be of MT. Okay, the value of the probability should be empty. Then these type of events are known as the mutually exclusive events. Similarly, next we are having the independent event. Independent event means two events are said to be independent if the outcome of one event does not affect the outcome of another. What is it? We know the meaning of independent. Independent means it should not depend on anything. In such cases, it is known as independent. Two events are said to be independent if the outcome of one event does not affect the outcome of the other. Okay, here there is one example. Taking a cab to market has no effect on finding your favorite movie on YouTube. Okay, here taking a cab to market is one event and finding your favorite movie on YouTube is another event. But these two events will not have the common effect. Will not have the common effect. Even though the two event is separated, it is not having the common effect. That is cab to market as well as favorite movie on YouTube, or the two events, but there is no common effect. And these types of events are known as the independent events. Next one is axioms of probability. Axioms are conditions of probability. To find the value of the probability, we are having some condition. That is, for any event capital E, the probability of E is defined as P of E equal to N of E divided by N of S. Here E is nothing but the event. P of E is nothing but probability of the event equal to N of E. N of E is nothing but N number of items in the event E divided by N of S. N of S is the total number of events in sample space capital S. Okay. Here we are having some axioms. Axiom 1, axiom 2 as well as axiom 3. What is axiom 1? That is that the value of the probability should be lies between 0 to 1. that is 0 less than or equal to P of E less than or equal to 1. So in any case, the value of the probability should lies between these two values. You came across the probability value 0.123, 0.789, 0.573. Okay, these are all the values of the probability. In no cases, the value of the probability is minus 0.123, minus 0.175. Okay. Likewise, in no cases it is 1.71, 2.83. Okay. So the value of the probability should be lies between 0 to 1. It should not less than 0, and as well as it should not be greater than 1. Okay. This is the first axiom. The second axiom, that is P of S. P of S is nothing but probability of the sample space equal to 1. P of S equal to 1. Here it is also known as the total probability. Total probability of the event. The total probability of the event must be equal to 1. For example, if I am tossing a coin, if I am tossing a single coin, means what will be the sample space? The sample space S is defined as H comma T. Either the head appears or the tail appears. The probability of head is 1 by 2. Similarly, the probability of tail is 1 by 2. If I am adding these two values, 1 by 2 plus 1 by 2, then that is equal to 1. That is the total probability. Okay. Next, axiom 3. Axiom 3, for any sequence of mutually exclusive events. Mutually exclusive means what? The intersection of any two events should be empty. Okay, that is events for which EI intersection EJ equal to empty when I not equal to J. That I should not be equal to J. Okay, then P of probability of the intersection of EI can be taken as summation P of EI. Summation P of E, that is probability of intersection of the events equal to summation of the individual probability. Summation of the individual probability. These are all the axioms. These are all the axioms we have seen here. Okay, these are all the axioms or conditions. Next one is the conclusion. What we have concluded here in this content, first we have seen about what is probability and some basic concepts, that is experiment. In that experiment we are having deterministic experiment and random experiment. Next one is the sample space. Sample space we are having discrete case as well as the continuous case. And next one is the event. In this event there are two types. Only the there are two types, the mutually exclusive event as well as the independent event. Finally we have seen the axioms of probability. That is the conditions of probability. Here we are having three axioms, the axiom 1, axiom 2 and axiom 3. If these conditions are satisfied, then the probability will be calculated according to these conditions. Okay, thank you.